Hi guys!
So I'm Roxanne Ramos.
I'm Jason Tapang.
I'm Garcia
From ECE31, and in this video, we are going to apply all the knowledge we have learned from our previous experiments.
So in recap, we already talked about simplifying Boolean expressions with Boolean laws that will be also applied in the problem later.
We also talk about the Carnot maps or K-maps, wherein it uses graphical techniques to simplify Boolean expressions.
Lastly, we can apply the simplified Boolean expressions using logic gates in actual circuits.
So in this video, we are going to solve the chemical tank problem. A chemical plant needs an alarm system to warn of critical conditions in one of its chemical tanks. The tank has 4 high-low switches that monitor temperature, pressure, fluid level, and weight. Using our knowledge in switching theory and logic design, and from our previous experiments, we will design and construct a circuit that will sound the buzzer if any of the following conditions are met. We have 4 variables to consider for the following chemical alarm system to trigger.
The chemical tank alarm system will trigger in these 4 conditions. First condition is, the chemical tank alarm system will trigger when it detects high fluid level with high temperature and high pressure. The second condition, it will trigger when it detects low in fluid level with high temperature and high pressure. The third condition is, it will trigger when it detects low in fluid level with low temperature and high pressure. And the last condition is, it will trigger when it detects low in fluid level with low weight and high temperature. To solve this problem, we are going to use the concept of Boolean Algebra and K-map.
With these conditions, the Boolean expression can be written as alarm is equals to LTP plus L prime TW plus L prime T prime P plus L prime W prime T, wherein L prime represents as low fluid level, L represents as high fluid level. To simplify the Boolean expressions, let's recall some of the Boolean laws: idempotent law, distributive law, De Morgan's law, commutative law, identity law, and complement law. As you can see, we mostly use the distributive law and complement law to simplify the Boolean expression of the given problem. So the simplified Boolean expression is alarm is equals to TP plus TL prime plus L prime P. And based on the simplified Boolean expression, it was observed that there was no weight input variable. Therefore, it can be said that the following Boolean expression was independent of the input W. The alarm triggers regardless of the weight value as long as the other conditions were met by other input variables.
We made 2 truth tables. For truth table 1, we included the weight or W variable. We also numbered per conditions for plotting the results in K-map. In our K-map based from the truth table, we were able to create 3 groups of 4. Using the K-map, the minimized expression was alarm is equal to L prime T plus L prime P prime plus TP. For truth table 2, we only use 3 variables: fluid level or L, pressure or P, and temperature or T. We also numbered each conditions to plot it easily in the K-map. In our K-map, based from the truth table 2, we were able to group 3 pairs where the result from the conditions is logic 1. Using K-map, the minimized expression is alarm is equal to L prime T plus L prime P prime plus TP. It was observed that we were able to gather the same Boolean expression using the Boolean simplification and K-map method. It was also observed that we can have the right answer with or without the weight or W variable.
For the schematic diagram, we can create 3 circuit design to satisfy the conditions of the given problem. For the first circuit design, we can use 3 2-input AND gate, 2 NOT gate, and 1 3-input NOR gate. The circuit diagram used the 3 input variables based from the simplified Boolean expression and the minimized expression using K-map based from truth table 2. Second, we can use 3 2-input AND gate, 1 NOT gate, and 1 quad input OR gate. This circuit diagram included the weight W input variable and was able to satisfy the conditions and results in truth table 2. Lastly, we can use 3 2-input AND gate, 1 NOT gate, and 1 3-input OR gate. For the application in actual circuits, we opted to choose the first circuit design based on the availability of the materials in our area. So the materials we use for the actual circuit is a 7427 3-input NOR gate, 7404 Hex Inverter Gate or NOT gate, 7408 quad 2-input OR gate, LED, connecting wires, power supply, and a 5-volt buzzer.
Para sa actual circuit, gagamit tayo ng tatlong IC. Yung una, 74LS08N na isang AND gate, 74LS04N na isang NOT gate, 74LS27N na isang triple NOR gate. So sa problem na to, madaming pwedeng circuit designs, pero ito lang yung available, yung triple NOR gate. Papakita ko naman dyan kung paano yung connection na gagawin natin para masatisfy yung condition sa problem. So yung input natin nakabase sa simplified Boolean expression na ginawa natin kanina. Ang first input natin yung T or yung temperature. So nakakonect siya sa first slot ng AND gate dito sa 1A. Tapos nakakonect din siya sa first input ng third AND gate natin. Mag-connect tayo dito sa 13th slot. Yung second input naman natin, yung P or yung pressure, nakakonect siya sa second slot ng first AND gate natin dito sa 1B. Tapos nakakonect din siya sa first input ng second AND gate natin dito sa fourth slot sa 2A ng AND gate. Yung third input natin na L or fluid level, dadaan muna siya sa NOT gate. Tapos yung output dito sa NOT gate sa 1Y, naka-input siya sa second and third AND gate dito sa 74LS08N. So mag-connect tayo dyan. Yung slot, yung isa. Tapos naka-connect din siya sa fifth slot ng 74LS08N dito sa second AND gate. Tapos yung output ng T, 1Y dito sa third slot, kukonect natin dito, triple NOR gate natin. So dito sa first slot, 1A. As yung output naman ng second AND gate natin, input natin sa second slot or sa 1B ng triple NOR gate natin. As yung output naman dito, kukonect naman natin input dito sa 13th slot ng triple NOR gate. As yung output naman nito, lalagay naman natin sa NOT gate. Mas preferable triple OR gate. Pero ito lang yung available triple NOR gate. So ang gagawin na natin, yung output niya, papadaan na lang natin sa isang NOT gate. Itong output niya, nakakonect sa 2A or sa third slot ng NOT gate. 2Y or fourth slot, connect natin dito. Mag-connect tayo ng resistor. So para sa experiment na to, gagamit tayo ng 5-volt buzzer. Mahaba yung positive niya. Para may connection din tayo ng isang LED. Tapos yung negative ng buzzer at saka LED, tuloy natin sa ground. 7 slots ng IC, ground din. Tapos 14 slots ng IC, VCC. Connect natin yung input natin sa ground. Yung violet na connecting wire, siya yung L or fluid level. Orange, yung pressure naman. Lagyan natin sa ground. Tapos yung blue is yung temperature. Positive terminal, negative terminal. Input L, P, and T, logic 0, output logic 0. Input L and P, logic 0. Input T, logic 1, output logic 1. Nakita nyo yung LED umilaw at saka may marinig kayong buzzer. Input L, logic 0. Input P and T, logic 1, output logic 1. Input L, logic 1. Input P and T, logic 0, output logic 0. Umilaw. Input L and input T, logic 1, output logic 0. Input L and P, logic 1. Input T, logic 0, output logic 0. Input L, P, and T, logic 1, output logic 1. Umilaw din siya. So makikita yung truth table, nag-alarm lang siya majority kapag logic 1 yung pressure at saka yung temperature. So ibig sabihin, sa chemical tank alarm system natin, mag-a-alarm yung system natin kapag yung pressure and temperature is nag-exceed na ng kayang i-handle ng chemical tank. Kapag fluid level na yung nag-exceed, hindi siya mag-a-alarm. So kailangan, para mag-alarm yung system natin, either pressure or temperature nag-exceed, pressure and temperature, at saka fluid level, pressure, and temperature. Any combination with L like LP or LT, or fluid level or temperature, fluid level or pressure, hindi siya mag-a-alarm. Mag-a-alarm lang yung chemical tank alarm system natin sa fluid level kapag yung pressure and temperature is nag-exceed din.